2.1 talks about derivatives and rate of change, and here we are. The tangent line to a curve y equal f of x at a point a, f of a, is the line through P with a slope of limit as x approaches a of f of x minus f of a over x minus a. This is going from a f of a in general to x f of x. So y2 minus y1 over x2 minus x1. Or we have another form for it. If you run from a f of a to a plus h f of a plus h, the same deal happened. y2 minus y1 over x2 minus x1. So we have two of those. We have one form and the next. The only reason I'm pointing that out because the homework picks equation 1 and equation 2. They want to make sure that you use both. So I start off by touching on all the kind of different combinations that you come across. One of them is polynomials. Find the slope of the tangent line to the curve at the point 1, 0. Use both equations 1 and 2. Then find the equation for the tangent line. So we want to find the slope. The slope of the tangent, let's use the first one. So at the point 1, 0, slope of the tangent is going to be the limit as x approaches 1 of f of x minus f of 1 over x minus 1. That's number 1. The slope of the tangent is going to be the limit as x approaches 1. F of x is x minus x squared. F of 1 is a 0 over x minus 1. So if you factor an x out of the top, that's 1 minus x. And those are, of course, a negative 1. That will be the limit as x approaches 1 of negative x. Substitute n, and that's a negative 1. By the way, if you are to put x equal 1, you'll get 0 over 0 at every step of the way, which is why we're simplifying. This is using 1. If you want to use 2, you would say, well, we're going to go by the limit. So the slope of the tangent is going to be the limit as h approaches 0 of f of, in this case, a is 1 plus h minus f of 1 over h. So the slope of the tangent, or you could do it a plus h and plug in 1 at the end for a, same thing. Limit as h approaches 0. F of 1 plus h is 1 plus h minus 1 plus h squared. Kind of what we did in the last example, in the last problem. F of 1 is a 0 all over h. That's the limit as h approaches 0 of 1 plus h minus 1 plus 2h plus h squared. That's the limit as h approaches 0 of 1 plus h minus 1 minus 2h minus h squared. And you notice the ones cancel out. And I could combine those. Take an h out. That will be 1 minus 2, which is negative 1 minus h squared over h. And we'll notice that's the limit as h approaches 0 of negative 1 minus h squared. If you throw h equals 0 and you get a negative 1. So that's part A. The second part, find an equation of a line, call it B. Well, y minus y1 equals m into x minus x. There it is, done deal. If I look at the next problem, find the slope of the tangent y equal 1 over radical x at x equal a, then evaluate it. So here, instead of doing this twice, 1 for x equal 1 and 1 for x equal 9, why don't I do it for x equal a, and at the end plug in x equal 1 and 9 for a? Well, there it is. Which of those two you're going to use, whichever you want. I'm going to say the slope of the tangent equal the limit as h approaches 0. You could use equation 1 or 2 of f of a plus h minus f of a all over h. limit as h approaches 0. F of 1 plus a is 1 over the square root of a plus h minus 1 over radical a over h. Again, if you let h equal 0, you'll get 0 over 0. So you clear the fractions by finding the LCD for the top and the bottom combined, which is radical a times the square root of a plus h. This is missing a radical a. This is missing a radical a plus h. And this is missing a radical a times radical a plus h. And if you remember, we ignore the denominators and read the top. That's radical a minus square root of a plus h over h into radical a times the square root of a plus h. Now, there's only one way of proceeding with radicals. You multiply by the conjugate of this. The same radical a, change that sign. It's going to look really messy, but that's what it takes. So that would be the limit as h approaches 0. The denominator is all of this mess. You could combine this if you wish. You could leave them, doesn't really matter. The top is going to be the first squared minus the second squared. So I'm looking at the limit as h approaches 0 of a minus h over all of this mess. Those cancel out. That's the limit as h approaches 0, negative h over h. Those cancel out. Once you cancel those out, I'm going to write an extra step so you're not confused. Remember, I was getting 0 over 0 at every step of the way. Once I cancel the 0 over 0, I throw 0 back in. Negative 1 over radical a. If you put a 0 in there, that's radical a. Radical a plus, and if you put a 0 in there, radical a. A lot of radical a's. Negative 1 over, that's a. And that is radical a plus radical a is 2 radical a. You could leave it like that, that's fine. And now you could say, well, let's see. The slope of the tangent is negative 1 over twice a radical a. If I let, in the first case, if I let a equal 1, the slope of the tangent will be negative 1 over 2. And in the second case, if I let a equal 9, the slope of the tangent would be negative 1 over 2 times 9 times radical 9. That would be negative 1 over, that's a 3. 3 times 9 is 27, times 2 is 54. So if I had to evaluate the slope of the tangent at multiple points, it would be a lot more beneficial for me to find the slope of the tangent in terms of the general a and replace a by values. Velocity, instantaneous velocity. The velocity at a is the limit as h approaches 0 of f of x plus a minus f of a over h, which is the slope of the tangent. So velocity, derivative, you could use either 1 or 2 to figure that out. And both of those mean the same thing, slope of the tangent. Now, this derivative business, a graph of a function is given. Example 3, a graph function is given. Arrange the following numbers in ascending order. So remember, this stands for the slope of the tangent. Derivative has many applications and many uses. So if I look at this, at -1, there's -1. If I want to draw a tangent line, kind of like this, well, the slope of that, let's say that's roughly 1. And if I look at 0, at x equals 0, the slope of this line, if this is 1, this is definitely bigger than 1. Let's say a 2. If I look at 3, the slope of this, well, the slope of horizontal line is always 0. And at 4, if I look at 4, the slope of this line is definitely a negative. Let's say -1. So if I want to put those in order, go -1, 0, 1, and 2, or I would pretty much go f prime of 4 goes first, f prime of 3 goes next, f prime of -1, then f prime of 0. That will be in ascending order. So a derivative has a lot of applications: slope of a tangent, instantaneous rate of change, velocity, many uses. Given y equal x cubed minus 2, find an equation for the tangent line to the curve at the point 1, -1, y minus y1 equal m into x minus x1. They're almost done. All what I need is the slope of the tangent. To find the slope of the tangent, that would be, I'm going to use the limit as x approaches 1 of f of x minus f of 1 over x minus 1. You could use either form. If it's a polynomial, it turns out this works out really efficiently. F of 1 is a -1. Remember, that's 0 over 0 at every stage. So we're trying to manipulate this. And we know what to do with rationals. We factor. If it's a radical, you multiply by the conjugate. If it's a complex fraction, you simplify. So if I throw a 1 in, because that's a polynomial, 1 plus 1 plus 1 is a 3. There it is, done deal. And I'm going to touch on the 3 types of problems that we come across. Find the slope of the tangent at x equal a. Those are the 3 types of problems that we see throughout this course, and I want to touch on each one of those. I'm going to take the limit as h approaches 0 of f of a plus h minus f of a all over h. Right? Slope of the tangent, derivative, velocity, it's the same. Limit as h approaches 0, 1 over a plus h plus 1 minus 1 over a plus 1 over h. Limit as h approaches 0. LCD is a plus 1 times a plus 1 plus h. So this is missing an a plus 1 minus. This is missing an a plus h plus 1. And this is missing the whole thing. That's the limit as h approaches 0 of a plus 1 minus a minus h minus 1, distributing the negative n. The 1's cancel out, the a's cancel out, and you notice the h's cancel out. And if I throw h equals 0 in, I get a -1 over a 0 in there. I'll get a plus 1 times a plus 1, which is a plus 1 squared. Now, if I look at the next example, a radical, same deal. I would say the slope of the tangent is the limit as h approaches 0 of f of a plus h minus f of a over h. That is the limit as h approaches 0 of the square root of a plus h minus 3 minus the square root of a minus 3 over h. Not much I could do with this except multiply by the conjugate. That will be the limit as h approaches 0. The top will be a plus h minus 3 minus a minus 3 divided by h times the square root of a plus h minus 3 plus square root of a minus 3. Distribute the negative n. A plus h minus 3 minus a plus 3. The a's cancel out, the 3's cancel out, and again you notice that h cancel with that h, you're left with the 1 at the top. And if you put an h equals 0 in there, you get the square root of a minus 3 plus the square root of a minus 3 is twice the square root of a minus 3. And if you go for the last piece, the slope of the tangent is the limit as h approaches 0 of 1 of f of a plus h, that's 1 over a plus h cubed minus 1 over a cubed over h. That is the limit as h approaches 0 of a cubed minus a plus h cubed over h times a cubed into a plus h cubed. That is the limit as h approaches 0 of a cubed minus a cubed plus 3a squared h plus 3ah squared plus h cubed all over h, a cubed into a plus h cubed. That is the limit as h approaches 0. If I factor an h out of this, I'll have negative 3a squared minus 3ah minus h squared. So remember, the goal is to get rid of one of the zeros, and once you do that, throw h equals 0 in, that will be 0, that will be 0, negative 3a squared, that will be 0, a cubed times a cubed is a to the 6, that's negative 3 over a cubed divided by a to the 6 is a cubed. A bit lengthy. And there it is. Now, they say the following limits represent the derivative of some function f and a. Find them. They're not saying find the derivative, they're saying find f and find a. So if I compare that, that's compared with the limit as h approaches 0, f of a plus h minus f of a over h. Well, notice, this part is right there, it's matching. The negative is right there, and this is matching. So, f of a plus h and f of a. I need to know what f is, so that when I replace it by a plus h, I'll get 3 raised to the 2 plus h. It looks like 3 raised to a power. And the h is right there. The h is right there. So can you guess what a is? Let's see. If I take f of 2 plus h, that would be this piece, minus f of 2. If you put a 2 in for x, would that be a 9? Yeah, that matches. There it is. If I match this second equation with the limit as x approaches a, f of x minus f of a over x minus a. This is a bit simpler because a is right there. So here we know a equals 2. That's easy. And f of x, it's much easier. It's right there. It's 1 over x squared. This, I don't have to do much work for. And the limit is, again, kind of like saying theta approaches a of f of theta minus f of a over theta minus a. Well, again, a is right there. We know that. A is pi over 6. And f of x, well, isn't that right there? It's really f of theta, but it's all good. And that's pretty much it for this section.